So this is r square minus r minus 1 equal to 0. So it is of the form ax square plus bx plus c equal 0 now. What are roots of this quadratic equation? What are roots of this quadratic equation? Minus b plus r square root of b square minus 4ac by 2a. So that means what is r here? What is a here? A is 1, b is minus 1, and c is also minus 1. What is r? Minus b. Minus b means b is minus 1, minus of minus 1, plus r minus b square means minus 1 whole square, 4ac, 4ac by 2a, 2 into 1. This is nothing but 1 plus r minus root 5 by 2. One plus r minus root 5 by 2. Is that okay? Now, how many roots are there? We can call it as 2 roots. 1 plus root 5 by 2 is 1 root. And the second root, we can consider it as 1 minus root 5 by 2. There are 2 roots. Whether these 2 roots are real, are they real? Are they real?
Yes, sir.
They are real and distinct. If they are real and distinct, what is general form of solution? What is general form of solution to reconciliation? Here, f of n equals general form of solution. F of n equals to some constant d1 into 1 plus root 5 first root power n plus some constant d2 into second root power n. Is that correct? Is that okay? Is that okay? Okay. Now, so finally, what is f of n? F of n we got as 1 plus some constant d1 into 1 plus root 5 by 2 whole power n plus some constant d2 into 1 plus root 5 by 2 whole power n. For all n greater than or equal 0. But what are our initial conditions? What are initial conditions? What are initial conditions given to us? Initial conditions given to us. What are initial conditions? What are initial conditions given in the reconciliation?
F of 0 is 0 and f of 1 is 1.
F of 0 equals 0 and f of 1 equal to 1. Where d1 and d2 are constants. Now, how to find these constants? How to find these constants? At n equal to 0 is substitute in equation 3. N equal to 0 in equation 3. Then what is that we get? F of 0 equals to d1 into 1 plus root 5 by 2 whole power 0 plus d2 into 1 minus root 5 by 2 whole power 0. Is that okay? Because this is f of n it is, so n equals 0 if we substitute f of 0. What is value of f of 0? It is 0. We know that f of 0 is 0, f of 0 equal to, what is 1 plus root 5 by 2 whole power 0? Anything power 0, 1, d2, this is also 1. So what is that we have got? 0 equals to d1 plus d2. The same thing we can write it as d1 plus d2 equal to 0. This I call it as equation 4. Is there any doubt at this point? There any doubt? Now consider n equal to 1. N equal to 1 in equation 3. Equation 3. So what is that we get? F of 1 is d1 into 1 plus root 5 by 2 whole power 1 plus d2 into 1 minus root 5 by 2 whole power 1. Is it okay? So what is f of 1? 1. F of 1 is 1. 1 equal to d1 into 1 plus root 5 by 2 whole power 1 is same thing. d2 into 1 minus root 5 by 2. This is say equation 5. We have two equations and two unknowns. Is it possible to solve for d1 and d2? Two equations and two unknowns. Can you solve for d1 and d2? Solve 4 and 5. Okay, 4 and 5. Then what is that we get? That okay, no, I'm not going to do here. D1 will get it as 1 by root 5 and D2 minus 1 by root 5. So therefore, if we substitute back these values in equation 3, then finally we will get know what is f of n. Therefore, f of n is what is f of n? 1 by root 5 into 1 plus root 5 by 2 whole power n plus minus 1 by root 5 into 1 minus root 5 by 2 whole power n for all n greater than or equal 0. Now again 1 by root 5 we can take common, no? So if we take 1 by root 5 common, therefore f of n can be written as f of n equals to 1 by root 5 if we take common. This is say equation 6. 1 by root 5 if we take common, this is 1 plus root 5 by 2 whole power n minus 1 minus root 5 by 2 whole power n. What is f of n here? 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 Are you following or not? This value is
F of n minus 1 plus f of n minus 2.
that is okay. That is recursive formula. This is f of 0. This is f of 1. No, this is f of 2. Is that correct? Similarly, this is f of 5. This is f of 6. Is that okay? In this sequence, Fibonacci sequence, what are the corresponding terms there? No, the corresponding terms. Is that okay? Okay. Now this is called direct. This is actually denoted as 0th Fibonacci number. This is first Fibonacci number. This is standard notation. Capital F stands for Fibonacci, 0 subscript. 0th Fibonacci number. F1 second Fibonacci number. F2. This is F2 is also 1. F3 equal to 2. F5 is 5. F6 is 8. So these are like this. So this is called direct formula or closed form expression for nth Fibonacci number. Nth Fibonacci number. So nth Fibonacci number is, it is same as Fn. Nth Fibonacci number, it is the formula. Is it clear? Is there any doubt up to this point? Now, what? Okay, let me write F0, F1, F2, F3. This is standard notation for representing Fibonacci numbers. F5, F6, F7, F8, F9, F10, F11, F12. It goes like this. What is F0? What is F0?
0.
0. What is F1 is 1. F2 is also 1. F3 is 2. It is 3. This is 5. This is 8. 13, 21, 34, 55, 89, 144. It goes like this, no? It goes like this. So this is nth Fibonacci number. Nth Fibonacci sequence in it. Now, what is that we are actually looking for? What is that we are actually looking for? Our intention is to solve which recurrence relation? To solve this recurrence relation, no? T of n minus 1. So here again, we'll come back to this. So what is the recurrence relation here? This is the recurrence relation, no? This is recurrence relation. So what are the terms in this recurrence relation? What is T? Okay, let us write. What is T of 0, T of 1, T of 2, T of 3, T of 4, T of 5, T of 6, T of 7, T of 8. Please tell me what is T of 0? What is T of 0? 1. T of 0, it is given as 1. What is T of 1? What is T of 1?
1.
Also 1.
What is T of 2? T of 2 is not 2, no. T of 2 is T of n equal to 2 if we substitute. T of 2 is T of 2 minus 1 plus T of 2 minus 2 plus 1, no. This is T of 1 plus T of 0 plus 1. What is this? 1 plus 1 plus 1, it is 3. Is that correct? T of 2 is 3. Is it okay? What is T of 3? What is
5.
T of 3?
5.
It is 5. What is T of 4?
9.
What is T of 4? It is 9. T of 5? 15. This is 25. It goes like this. It goes like this. Okay. Okay, we'll come back to this after. So now find what is our reconciliation. Let us write it here. T of n is T of n minus 1 plus T of n minus 2 plus 1 if n is greater than or equal to 2 and T of 0 equals to 1. T of 1 is also 1. If that is correct, this is given to us. This is given to us. Now, is it a homogeneous reconciliation or non-homogeneous reconciliation? Is it homogeneous or non-homogeneous? Is it homogeneous or non-homogeneous? Is it homogeneous or non-homogeneous? It is non-homogeneous. Like this, other terms are not allowed in homogeneous. Okay. So because we don't know how to solve non-homogeneous, with a small modification, okay, we can bring it into homogeneous form. What is that we do is this reconciliation minus 1 is there, add plus 1 and subtract, add 1 and subtract 1. Add plus 1 is this okay? Is it okay? Now group these terms, T of n, this. So this can be written as T of n plus 1 minus this term and this term we can group. T of n minus 1 plus 1 minus this remaining two terms we can group. It becomes T of n minus 2 plus 1 equal to 0. Is that okay? Is that okay? You see, for all n greater than or equal to 2. So now it is of the form Tn plus 1, Tn minus 1 plus 1, Tn minus 2 plus 1. So now let us let S of n equals to Tn plus 1. Then what happens to this? Let S of n equal to Tn plus 1. Then what happens to this reconciliation? S of n minus S of n minus 1 minus S of n minus 2 equals to 0. Is that okay? Is that okay? And what are initial conditions? What is S of 0? What is S of 0? What is S of 0? See, S of n is T of n plus 1. What is S of 0? What is S of 0?
2,
T
sir.
of 0 plus 1. Is there any confusion here? Is there any confusion?
No, sir.
Okay. What is T of 0? It is no. It is 1 plus 1. It is 2. Now what is S of 1? T of 1 plus 1. N equal to 1 if I substitute. T of 1 plus 1. What is T of 1? That is also 1. So it is 2. It is 2. Is that okay? Is that okay? Okay. Now, so what is this sequence? Yes. What is this sequence? Yes. S of 0, S of 1, S of 2, S of 3, S of 4, S of 5, S of 6, S of 7, S of 8. What is this sequence? Yes. What is S of 2? It is 2. S of 0 is 2. S of 1 is 2. What is S of 2? What is S of 2? What is S of 3? What is S of 4? Is it correct? Is that correct? Is that correct? Now what is, now without even solving this, what is F0, F1, F2, F3? What is F0? 0, 1, 1, 2, 3, 5, 8, 13, 21, 13, 21, 34, 55, like this. 55 like this. simplify like this. So is there any relation between this sequence and this sequence?
The next term is the addition of previous two terms.
In both that condition is true.
Hmm.
For example, S4 if S2 if I take, what can we say about in terms of F's here?
F1 plus F0.
No, that is not true, no.
S1
No.
plus S2.
Hmm?
S1, yes, sorry, S1 plus S0.
That is okay, that is correct. In terms of F's,
Okay.
only one F we need to say. Only one F. If that is not possible, again we need to solve this reconciliation. Again we need to solve this reconciliation.
N is 2 times of Fn plus 1, sir.
What, brother?
Yes, N is 2 times of Fn plus 1, like that.
So what he's saying is S2 if I take, S2 if we take, it is 2 times this. Is that correct, brother, what you are saying?
Sir, yes, sir, like that only. For S, from S naught itself, we can see that pattern, sir.
From S0, it is 2 times this, it is 2 times this, it is 2 times this, see. 2 times, here it is 2 times. Okay, let me take some other color. This is 2 times if I take this is 2 times, this is 2 times. Is that correct? Is that
Yes,
correct?
sir.
So now you tell me what is Sn, directly we can write now. What is Sn?
2
What is
into
Sn?
2 times of Sn minus.
What is Sn?
2 times of Fn plus 1.
2 times Fn plus 1. But we don't know Sn. No, our interest is only we need to find what? We need to find what? Solution to this reconciliation. No. That means what is the value that we need to find? Tn only, no? Our actual reconciliation, no. That is T of n is T of n minus 1, P m minus 2 plus 1. What is Tn? What is T? Sn is Tn plus 1. That implies what is Tn?
Sn minus 1.
Sn minus 1. Sn is Tn plus 1. What is Tn? Sn minus 1. So therefore, what is Tn now? Tn can be written as Sn minus 1, which is same as 2 times f of n plus 1 minus 1. N plus 1 minus 1. What is this? This is 2 times. What is f of n plus 1? What is f of n plus 1? 1 by root 5 into 1 plus root 5 by 2 whole power n plus 1 minus 1 minus root 5 by 2 whole power n plus 1 now. Is that correct? Is that correct? Is that correct? Now what is order of growth of T of n? What is order of growth of T of n? What is order of growth of T of n? What is order of growth of T of n?
Exponential.
Exponential. Exactly. Can you tell us, sir, what is the order of growth of T of n? 1
1 plus root 5. We can simplify 1 plus root 5 by 2 power n plus 1.
N plus 1. Why? Because this is
Power
smaller
n.
term.
Yeah,
We are
power n,
subtracting here. So this term has less value. So 1 plus root 5 by 2 whole power n plus 1 is its order of growth. Is that,
Yes, sir.
is that clear to everyone?
Yes, sir.
1 plus, but 1 plus root 5 by 2 whole power n plus 1. We can also say that its order of growth is, we can write it as 1 plus root 5 by 2 into 1 plus root 5 by 2 whole power n. No? If I remove this, even we can say that it is n. Is that okay? Both are more or less same, no? Is that correct? Order of growth of 2 power n plus 1 and 2 power n. Both are same or not? 2 power n plus 1, can you write it as theta of 2 power n? Is this true or not?
Yes, sir.
If this is true, this should be automatically true, no?
Yes, sir.
Okay. So finally, what is 1 plus root 5 by 2 value? That is 1.8 something. 1.8 something. Okay. Now let us go back to our algorithm. Now again we are back to that algorithm. Okay. Back to that algorithm. So this is the algorithm. Here, what is the basic operation that we considered? What is the basic operation that we consider? Input size is n. What is the basic operation we consider? This is our basic operation. When we consider this operation as basic operation, this is comparison. When we consider this as basic operation, what was our T of n value? T of n is how much? 2 into 1 by root 5 into 1 plus root 5 by 2 whole power n plus 1 minus 1 minus root 5 by 2 whole power n plus 1. Is that correct here? Is that correct? Is that correct? What is its order of growth? 1 plus root 5 by 2 is this much. Oh, sorry, 1.618, not 8. 1.618. 1.618. And this value, no, it is known, it is called golden ratio. It is called golden ratio. If objects know if they are in this ratio, that will be very much pleasing to our eye, it seems. Okay. So now what is T of n's order of growth? T of n can be written as theta of 1 plus root 5 by 2 whole power n. Is this correct? Is this correct? T of n is theta of 1 plus root 5 by 2 whole power n. This is the order of growth. Okay, now running time of this algorithm. Only one line, but analysis is difficult. No, difficult means lengthy, not difficult, lengthy. Lengthy. That means this way of finding nth Fibonacci number, how much time it takes? Exponential time or not? Is it exponential time or not?
Yes, sir.
It's exponential. Okay. But there are simple algorithms. We can easily find it nth Fibonacci number in order of n time also. How to find in order of n time? How to find in order of n time?
Using iterative algorithm.
Sir?
Using iterative algorithm.
Iterative algorithm, simply one for loop we can write and find it, no? That we will discuss when we talk about dynamic programming. Why it is exponential, so how to reduce it to order of n. That we will discuss when we talk about dynamic programming. So now we know that nth Fibonacci number solving recursively like this, it takes exponential, that is theta of 1 plus root 5 by 2 whole power n, that is 1.618 whole power n time. Okay. Now instead of considering this comparison as basic operation, if I consider this addition as basic operation, then what is the reconciliation we get? What is the reconciliation we get? What is the reconciliation we get? Same, no? N equal to 0 means how many times addition is performed? If n equal to 0, how many times addition is performed?
0.
0 times, no? That's why T of 0 is 0. Is that correct? If n equal to 1, whether this else part is executed? No, that means no additions at all. That means T of 1 is, what is the value of T of 1 when this addition is considered? That is also 0. That is also 0. Now what is T of n? If n is input size, the time this algorithm takes, if I call it as T of n, what is time this algorithm takes? It is T of n is, for this, what is the amount of time? T of n minus 1. This part it is T of n minus 2 plus here one addition extra, no? Here one. So therefore T of n is T of n minus 1 plus T of n minus 2 plus 1. If you solve it, we will get this f of n plus 1 minus 1 similar to this. Here 2 is extra, here there is no 2. Okay. Again, order of growth is 1 plus root 5 by 2 whole power n. Both are same asymptotically or not? Both are same whether we do analysis for addition operation or that comparison operation. Both are asymptotically giving the same running time or not? Both are same or not? Order of growth in both cases, is it same or not?
Yes, sir. Same.
Yes. Okay, no. So that's why we should not. Okay, whether we take this operation or the other operation, value, exact value is different, but asymptotically both are same. Asymptotically both are same. Is it clear? Only thing is here we get a recurrence relation, but for that we should know how to solve recurrence relations and all. Later we will be seeing without even solving. Our interest is not solving recurrence relation. No, we are only interested in order of growth. Without even solving, if we are able to find its order of growth, then we make use of that method. If there are some methods which directly give us recurrence relation without even going for actually solving it, then we go for that methods. That's what we discuss. But that methods, no, those methods, they are not applicable for all types of recurrence relations. Only some selected type of recurrence relations. Okay. Now you tell me what this algorithm already we discussed. No, non-recursive version we discussed or not? Non-recursive version we discussed or not? Finding sum of elements of an array. Non-recursive variant we discussed, no, iterative algorithm. Here it is recursive algorithm, same. Okay, this is A of n. Okay, this is A of n. Okay, same algorithm. This is, how does it work? How does it work? How does it work? Last element we are keep on adding to. Last element we are from last to this, we are coming from nth position to first position. We are adding this. After that, remaining n minus 1 element sum we are finding. That is sum of elements of this array 10, 20, 30, 40. Is it same as sum of elements of this array 10, 20, 30 plus 40? Is this correct or not? Is that correct or not? Is that correct or not?
Yeah, correct, sir.
We actually, they have simply based on that only they have written recursive algorithm. No, it is again recursively they are finding sum of this. To that they are adding last element value. And what is the termination condition? If there is only one element in the array, 36. What is sum? What is sum? If there is only one element in the array, what is its sum?
Element itself, 36.
The number itself.
That number itself. That is nothing but array A of 1. No, A of 1. Is that correct? So that's why if there is only one element in the array, return A of 1. That itself is the sum. No. If there is more than one, if there are two or more elements, if there are two or more elements, this is for n greater than or equal to 2. If there are two or more elements, then what is that we are doing? First n minus 1 elements recursively we are finding sum. To find sum by using the same algorithm. Okay, recursive call. Then last element we are adding to that. Is that okay? Is that okay? Is it clear? The algorithm, is it clear? Okay, even without it, is the recursive algorithm clear or any doubt in this?
Clear, sir.
Yes, sir.
Okay, this same algorithm, whatever we discussed earlier. Okay. Now, what is input size? As usual, number of elements in the array. Input size is n. What is most important operation? This addition operation we consider as most important operation. That is basic operation. Basic operation. Now, number of times basic operation is performed. It depends only on n or actual values in the input also. It depends only on n or actual values in the input also.
Only on n, sir.
Only on n. That means, are there any best case, worst case, average case in this case? No, there are no such cases. All cases are same. Now, let T of n be the number of times this operation is performed when there are n elements in the array. That is, input size is n. N. So, well, here 5 elements are there. Here also 5 elements. I think this is by mistake. Here also 5 elements. Well, number of actual instance is different instance. Whether T of n value is it same or different? It's the same, no? It's same. It is same. Okay. Now tell me, what is T of n? Next to fourth step, what is T of n? What is T of n? Actually, can you go initial conditions here? What is T of 1? If n equal to 1, how many times addition operation is performed?
0.
0 times. If n is not equal to 1, we come to else part. Automatically one addition is performed or not here. So 1 plus. Again, we call this function with input size n minus 1. That means how much time does it take, or how many additions are performed in this part? How many additions are performed in this part?
T of n minus 1.
T of n minus 1. T of n minus 1. And this is if n is greater than or equal to. This is the reconciliation. Already we solved this reconciliation. No, same reconciliation or not? What is the answer? What is answered? What is T of n? What is T of n? Please.
N, sir.
No. Small change. What is answer?
Minus 1.
Madam?
Sir, I think n minus 1, sir.
Thank you, brother. N minus 1 is correct answer. Okay. Earlier we had T of 0 equal to 0. Now it is T of 1 equal to 0. No. T of 1 equal to 0. Initial condition is different. Okay. So T of n is n minus 1. What is its order of growth? Order of growth n. So that means what is running time of this algorithm? What is running time of this algorithm? Theta of n is also correct. Big O of n is also correct. Big omega of n is also correct. Is it okay? Is that okay? Is it clear or any doubt in this?
No, sir. Clear.
Because whether we write a recursive algorithm or non-recursive, running time, whether it changes, there will not be any change. Okay, there will not be any change.
Sir,
Okay.
T of n is equal to n minus 1. That I am not clear, sir. This one. T of n is equal to n minus 1.
1 plus T of n minus 1. Oh, solution to this recurrence you are talking about, sir?
Yes, sir. The last part. T of n is equal to n minus 1.
Okay. Oh, 1 minute. I just simplify it. This can be written as T of n minus 1 plus 1. Is that okay? Now, what is T of n minus 1? If T of n is
T of n minus 1.
N minus 1 plus 1. What is T of n minus 1? Wherever n is there, n minus 1 is substitute. What is this? T of n minus 2. N minus 2
plus 2.
plus 1. Already plus 1 is there. This is this plus 1. Is
Yeah.
it okay?
Mm.
Is it okay? So it is
Yes.
T of n minus 2 plus 2. Next time, if I substitute for T of n minus 2, what is that we get?
T of n minus 3 plus 3.
And so on after I times
T of n minus I plus
plus I.
I.
But what is the value that we know here? T of 1
T of
only we know.
1 is
When do we get 1 here? N minus I should become 1. That means what? I should become n minus 1. So
Okay.
at I equal to n minus 1, what is T of n? T of n minus 1 plus n minus 1. Is that okay? It is T of 1 plus n minus 1. What is T of 1? What is T of 1? 0 plus n minus 1. Is that okay?
Yeah. Okay, sir. Yeah.
Okay.
Thank you.
Same thing, because in order to analyze running time of recursive algorithms, we should know at least some basic methods to how to solve recurrence relations. This is substitution method, that's all. Okay. The other method which we use, that is characteristic roots method. Characteristic roots method. Now, please tell me what is running time of this algorithm? What is running time of this algorithm? Input to, okay, this is n, the time this algorithm takes, let us call it as T of n. T of n. What is most important operation here? What is most important? Okay, we can analyze algorithm without even knowing what does that algorithm do, no? Is it possible to analyze this algorithm without knowing what does this algorithm do?
Login times.
Yes, okay. So this is when n is given, the time this algorithm takes is T of n. What is most important operation here? If I consider this division, division I consider as most important operation. Okay, division I consider as most important operation. Now you tell me how many divisions are performed if n equal to 1? How many divisions are performed when n equal to 1?
0, sir.
Sir?
0, sir.
0,
No
0.
division.
Okay. If n is greater than or equal to 2, how many divisions are performed? Here, no divisions in the first step. We come to L spot. L spot number of divisions is, if n is given, T of n is number of divisions. If n by 2 is given, ceiling floor of n by 2 is given, how many divisions here? How many divisions here? How many divisions here?
1.
No. See, if n is input, it is same recursive algorithm. No, if n is input, number of divisions, I am calling it as T of n. If n by 2 is input, how many divisions?
Log n.
Same, that number only I am writing. Here T of that number I am writing. Here T of this number I am writing.
N by 4.
T of n by 2 only, no? T of n by 2. So now what is T of n? Please tell me. What is T of n? Please tell me.
T of n by 2.
2 plus.
So in order to calculate this, one division we have performed or not? One division we have performed or not? If you have any confusion, this division you replace with addition. Okay, no? This division you replace with addition. So this addition I call it as basic operation. Now what is, I think at least it is clear now. So what is T of n? Number of additions performed here plus one extra addition we are doing here. So this can be written as T of floor of n by 2 plus 1. Is that clear? Is that okay? Is there any doubt here? Is there any doubt? Is there any doubt? Okay, I proceed. Now we need to solve this reconciliation. We need to solve this reconciliation. Anyhow, we are interested in order of growth only. So if I don't want this float to have any impact, what type of values I need to choose for n? If I don't want this float to have any impact on n by 2, what type of values I need to choose for n?
Power k.
2 power k form if I choose, no? If n is of the form 2 power k, where k is greater than or equal to 0, floor of n by 2 is always same as n by 2. Is that correct? Is that correct? Okay. So now if I assume that n is 2 power k, then what is my recurrence relation becomes? T of n is simply T of n by 2 plus 1 and T of 1 is 0. We can solve this reconciliation now. T of n is T of n by 2 plus 1, T of 1 is 0. Is it similar to our binary search? Is it similar to binary search?
Yes, sir.
Only small change. T of 1, we had 1 there. T of 1, 1 no. Even if there is one element, number of comparisons is 1 no. So we can say that T of n is log n. T of n is log n. That means what is its order of growth? What is its order of growth?
Log n.
It is again log n. Base is not required now. When we write order of growth, base is not required. So therefore, what is running time of this algorithm? This can be written as T of n is theta of log n. Is this correct? We go off log n. It is, if once theta of log n is correct, automatically this two will be correct. No. Is that correct? Only thing is, you need to know up to this. If you are able to understand, that is fine. Up to this reconciliation. After that, it is solving reconciliations. After that, it is solving reconciliations. And after some class, we also will be discussing how to find order of growth of this type of reconciliations without even solving it. That we will discuss. Maybe it takes some time, maybe 1 or 2 classes. We will discuss how to find its order of growth without even solving. Without even solving. Is it okay? Now tell me, what is running time of this algorithm? Simple recursive algorithm. Okay, let me define here. T of n is
Log n, sir.
madam, that okay, that we'll see. Okay. Now number of, first if we tell reconciliations, automatically after that we can number of
Okay.
times say algorithms is printed.
Log n, I think so, sir.
That okay, madam. Just 2 minutes, we will get answer. Okay. Is displayed or printed. Let here be the number of times algorithms is printed when n is input. When n is input. Now you tell me what is T of 1? What is T of 1? If n equal to 1, how many times algorithms is printed?
1 time.
Only 1 time. If n is not equal to 1, so this entire algorithm time we are saying it as T of n. T of 1 is 1. If n is not equal to 1, if n is greater than or equal to 2, so we come to else part. That means these 2 lines are executed. Here, 1 time it is printed or not? 1
Yes,
time it
sir.
is printed or not? Is it okay? Now again,
Yes.
here how many times it is printed? How many times it is printed?
T of root n times.
Thank you, sir. So if we, I think you have many people, I think they are not able to understand this. When n is input, the total number of times basic operation is performed is T of n. When root n is input, how many times it is performed? T of root n only, no?
This is the point we are not getting, sir. Actually,
No, when n is input, madam, when n is input, number of times it is printed, algorithms or whatever it may be, is printed is T of n. When root n is input, this is same algorithm, no? Display of root n. In place of n, we have root n. Then what is the time it takes? T of root n, no? Actually, there we are not doing anything, literally. Simply
Okay.
whatever T of n is there, that I am replacing with root n. Correct, no?
in all the algorithms that we have seen so far, all the recursive algorithms, the recurrence relation we are doing like this only, no, sir?
Ah, yes, madam.
But recursive call, in that recursive call, just we are replacing with the T of, if it's
Root n.
suppose Fibonacci
T of root.
series,
Correct only.
we are replacing with T of n minus 1 plus T of n minus
that
2.
that example also, okay, next example is that type only, that also we'll see. Okay, now is it clear?
Yes, sir.
T of n is, if n is greater than or equal to 2, we first execute this fifth step. It is repeated one time. After that, how many times it is repeated? T of root n times. So T of n is T of root n plus 1. Can you write like this?
Okay.
Okay. But root n, how to simplify it? How to simplify it? So let us take n equal to of the form 2 power k. Then what happens? T of 2 power k is T of 2 power k by 2 plus 1. Is that okay? T of 2 power k is T of 2 power k by 2 plus 1. Now let us take S of k equals to T of, let S of k equal to T of 2 power k. S of k equal to T of 2 power k. Is that okay?
Yes.
Now, what is S of k by 2? If you know this, then what is S of k by 2? Wherever k is that, k by 2. T of 2 power k by 2. Is that correct? Is that correct? Is that correct? Is that
Yes,
correct or not? So now what happens to this recurrence relation? In S of k equals to S of k by 2 plus 1. Is that okay?
Yes.
Now we know how to, now what is say S of 0? What is S of 0?
Now, for this log n is the solution. S of
No,
k is
T of 2 power 0. What is T of 2 power 0? T of 1. What is T of 1? We know that it is 1. So that means what is our reconciliation? S of k equal to S of k by 2 plus 1. S of 0 is 1. S of 0 is 1. It is ditto same as binary search reconciliation or not?
yes, sir.
So now what is S of k?
Log k.
Approximately log k we can write. Okay. Is that okay?
Yes.
What is the order of growth of S of k?
Theta of
Log k.
log k.
Order of growth is later we can represent. Okay. Order of log k. But what is that we are looking for?
K.
What is S of k? S of k is nothing but T of 2 power k. T of 2 power k is log k base 2. What is 2 power k? 2 power k is nothing but n.
Log n.
So T of n is this log k base 2. But here I have function in terms of n, but here k is there. If n equal to 2 power k, what is k?
Log n.
Log n base 2. So what is that we get here?
Log n.
Log of k is log n base 2. So it is, what is order of growth? Order of growth is log of log n. Now what is running time of this algorithm? T of
Log
n
of
can be
log
written
n.
as big O of log n. Is this correct? Is that correct?
Yes,
Is that
sir.
correct? It's big omega of log n. Is this correct? Theta of log n. This is also correct. Now if I write here T of n is theta of log n, is this correct? T of n is theta of log n, is this correct?
No, sir.
No, this is not correct. Naam ke vaste, if you want, we can write like this, but it is correct definition wise, but we don't write. Why? Because we know that its order of growth is log of log n. This is correct, but useless answer.
Log n is greater than log of log n, sir.
Very much. That's why it is correct. No. Here order of growth is log of log n. That means what? Log of log n is big O of log n or not? Correct. That's why it is correct.
Okay.
See, T of n means only we should have its order of growth in mind. Order of growth is log of log n. So log of log n can be written as big O of log n. Yes. Hence it is correct.
Sir, this algorithm, will it terminate, sir? Suppose if n is equal to 8, for example.
N
Will
equal?
it satisfy? Suppose 8.
Okay, in that case, we can put here C log floor.
Okay.
Because any value comes down, no, sir.
Okay. Okay. Yes.
If I want, I can put it here, floor or ceiling. If we have that, kind of floor or ceiling, then I think it automatically terminates, no?
Oh, okay, sir. Okay.
Or if you want that condition, here I'll put it less than or equal to 1, whether it terminates.
Yes. Yes. Okay, sir. Yeah.
Okay, that things we can adjust. Because actually recursive algorithm, that boundary conditions only difficult. Okay, no, that we should carefully write. We should carefully write. Okay, here if I put less than or equal to 1, then it's fine now. Okay.
So very less number of times this algorithm is
that is printed because running time is log of log n. No, it is very less, madam.
yes.
In this case, okay, with this I stop. Last example. Okay, directly we write
T of n minus 1 plus 1.
plus 1. N is greater than or equal 0. N is greater than or equal 2. T of 1 is 1. So what is the answer we get? What is the answer we get?
N minus 1.
Theta of n. Is it correct?
Yes, sir.
In this case, what is that we get?
For I is equal
Is
to
this correct? Is this correct?
yes, sir.
Now we need to know how to solve this. I request all of you to solve this. We'll discuss in next class. So
Okay.
once you know how to analyze recursive and non-recursive algorithms properly, after that actual things, no, any algorithm is given that is either recursive or non-recursive. Okay, so in no time we can analyze those algorithms, any algorithm, standard algorithms, no, all sorting algorithms, searching algorithms, or minimum spanning tree related, or okay, no, shortest path related, anything we can easily analyze. Okay.
Sir, because here for loop is there in the else part, that's the reason it is n, sir. Plus
That's
n.
all, madam. That's all. Correct.
Sir, we are not adding 1 here. 1 generally, if n is equal to 1, no, that can.
No. See, if n equal to 1, then only it is one time. If n is not equal to 1, this part is not executed at all. No, if part.
Okay.
See, what I am counting here is how many times this is printed. My T of n is this. If I consider T of n as this, then recurrence relation will be a bit different. No, here I will. What is the recurrence relation?
Yeah, then in that case, plus 1, I think we will get.
Only simply T of n minus 1 plus 1 we get.
Yes, I
So
got
here
it.
actually, I am counting how many times T of n is this. Number of times algorithm is displayed, algorithms is printed when n is given as input. That's what we are counting. Oh, actual running time, no, it is depending on this only, no.
Yeah, I got it, sir. Yes. Thank you, sir.
Okay. Okay, I stop here.
N
Thank you.
equal to 1. Even if we consider n equal to 1, how it come at
Hello.
yes, sir?
Sir, you are asking something?
Yeah, sir. Here you said, if it is, we consider n equal to 1, we can place t of n minus 1 plus 1, right?
T of n minus 1, because correct only, no. See, if n
No,
equal
sir,
to
in
1
that case also, we focus on the count, no operation count. In that case also, the recurrence relation will be same, only the initial condition would be different.
No. So in that case, what is recurrence relation? If I am only counting n equal to 1, how many times n equal to 1 is printed? Okay, no. If I am counting this, recurrence relation will be entirely different. No, T of n is 1 plus number of times it is here. Correct? No. Running time is different. In this case, running time and this both are different. No, sir. This number of times this is printed, it is more. No. Running time of algorithm, this is correct. Running time of algorithm is actually this. Here, whatever work we are doing is less when compared with what is the work we are doing here. Hence, running time, we cannot say that it is n. Running time of this algorithm is n is wrong.
Yeah, that's I want to say.
That is not correct. Why? Because you are counting the operation which is repeated less number of times. There are actually some other operations which repeat more number of times. No, here actually comparison is performed, even increment, that means addition operation is performed inside here. This become our most important operations, no, sir.
Then it is clear, sir.
Okay. Thank you. Okay. If there are any no doubts, I stop sharing. Thank you. See tomorrow.
Thank you, sir. Yeah.
Thank you.